All right, well, thanks a lot everyone for coming. So yes, I'm the co-founder of Ably, which is a real-time messaging platform. We provide functionality to real-time functionality for developers, so effectively APIs to help add sort of functionality to their apps, such as chat apps or live streaming of data, or sort of collaboration apps like things like Google Docs and stuff like that. So obviously I'm actually using Google SlideShare now, so that sort of real-time functionality is the types of things we do. I suppose the point of this talk is I'm going to tell you a bit about the history of web technologies and then how that applies to real-time technologies and some of the problems we're facing. And sort of before I get all nostalgic about the technologies that sadly I can remember being around, I kind of want to just explain what I mean by sort of data at rest and data in motion. And oddly, I sort of thought about this when I was skiing once, and in a place called Triel, which is this in the Alps. And what Triel has is they've got a big glacier, and back in the sort of early 19th century, there was the ice industry. And so what used to happen is literally people would cut up ice off the Alps, and it actually started in America, but in sort of mid to late 19th century, Europe also started to sort of ship ice from the Alps. And it was kind of interesting because if you think of the sort of what ice represents, there was a sort of transaction of they needed to cut it up and ship it, and the value of that ice decreased as the longer it took to kind of get it there. And in many ways, it's a bit like sort of data in motion or data at rest. Data at rest, typically the value is intrinsic, and it doesn't really matter if it's moving. Whereas data in motion, the sort of the timeliness, the relevance of how quickly you get that data there is about how valuable that data is. So the ice industry is quite a weird sort of analogy to draw, but it all kind of fell apart in the sort of early 20th century because refrigeration came in. So that was kind of the reason why the ice age, but the ice industry sort of stopped. But the interesting thing is, again, there was another analogy that I kind of drew, which is the still fundamental thing of creating ice was still the same. Like, it was a shipment of water, but that was done by pipes, and that was effectively like a stream of data. And if you think of data in motion, you'll often find in the real time world people talk about streams, pipes, fire hoses, and that sort of principle that things are moving constantly, that you're not having a sort of a process of someone asking for something and someone getting something back. There's no sort of request. It's just a constant stream of information. That's kind of what sort of real-time data is. This is a stream of information, and the faster you get it there and the quicker you get it there without someone asking for it, the more valuable it is. So I thought before I get started again into the sort of history, it would be good to just show you an example of something we built a little while ago, which is a good demonstration of real-time and data in motion. So, do you mind if I ask if whoever's got phones or laptops to just go to that URL, give it a lob, and I will do the same and open up another browser quickly. Yes, okay, so I can see two people, well there we go, three people now have decided that they wanted to do their phone. So does someone want to give me a code so I can just sort of demonstrate what's going on now? Who's on your phone, whoever's kind of doing the starter lab will have a code on the front of their phone. Has anyone got one?
Yep.
Yeah, what's yours?
FSAPB.
FSAPB. Okay, so I'll find yours. So if you show your phone, you'll see that in real time. So if everyone else goes back to the home page, back to the previous page that they're on, you'll see the FSAPB one as well, and you should all get a stream of of Tom's phone in real time. And do you want to give it a lob? Yeah, 15 centimeters. Not very ambitious. But I think the idea here really is just that, again, what's happening here is there's no, for you guys to, if you are looking at that stream live, there is no request or response mechanism. Like the traditional web is you send a request and you get a response back. And with this, what's happening is Tom's phone is streaming data to our platform, and then our platform is responsible for fanning that data out. And that's kind of the the underlying principles of how real-time sort of technology works. That you sort of got the stream of data that just keeps flowing. Yeah, so I mean, I think, the thing I want to try and do is just kind of explain the analogy that we talked about, data in motion, data in rest, and then kind of give you that summary of how internet technologies came about. So, I mean, if we start off, we've got, basically in the 1970s, there was a thing called DARPA, and they created TCP/IP, which is really the lowest level. I say the lowest level. There are always lower levels, but lowest level that anyone you would hear about in sort of networking technologies. TCP was invented, and that really set the sort of stage for the internet, and that devices anywhere in the world can communicate with each other, and they had a way of addressing each other. Like they had a way of you've probably heard of IP addresses, and sort of every machine had an addressable sort of space, and then computers could communicate with each other, and that was really the thing that when you look back is what enabled everything else to happen. Then Tim Berners-Lee came along, which we all know, Sir Tim, and he really spearheaded two major things. The first one was HTTP. So HTTP was in the 90s, so it was 20 years later, and HTTP was really a language that allowed clients, which is really, if you think of your browser as a client, and servers, which are typically people's server farms, it allowed them to kind of communicate to each other. So with a sort of standard, simple, and that was the sort of, I think the key thing about it, was a simple text-based language that allowed clients and servers to communicate with each other. But kind of going back to the analogies of data rest and data in motion, ICE and all that, this was designed for you send a request, so you have an IP address, you send a request to that server, and you get a response back. It's a very synchronous sort of process. And then the sort of next big set of technologies that came about was Tim Berners-Lee was involved in one of them, and not the other two, but the first one was HTML, and that's really just a markup. So it's all very well, we had ways that clients and servers can communicate, but there was no standardization around what data represented or how you would present that to people. And so HTML was really the first markup language that sort of helped browsers display information in a meaningful way. And then CSS and JavaScript were another two technologies that came within around the same time, but CSS was great, so we can display this content, but how do you display it? Like, do we make it bold or small? And so CSS was a sort of styling layer, and JavaScript was a thing that sort of added the sort of functionality, interactivity to web pages. And looking back, it's those three things, those three groups of technologies that there's a whole myriad of technologies that you could attribute the web to, but really it's those. Like, those are the things which built the web and kind of are still really powering the web today. The thing that's been interesting is that it's very hard. Those technologies have kind of significantly changed society and how people share information and really changed the world, but those technologies are also the technologies that everyone now relies on. So it's quite hard to change those, because you can no longer in isolation go and say, I'm going to introduce this new feature or spec. You have to get committees of people to agree to things, and committees never really do things quickly. But as an example, like HTML, I think when Tim Berners-Lee, I don't know when HTML4 was released, but HTML5 was first, I think, drafted in 2008. So there was a proposal because they had shortcomings in the version HTML4, and it took 7 years to get that approved. In this sort of web technology world, that's a crazy amount of time. And HTTP 1.1, which is what Tim Berners-Lee did, which is the protocol about clients and servers, it's taken, I think it's taken 18 years before HTTP2 was released. And if you think of sort of even TCP/IP is the sort of language, the sort of lowest level networking, and it's only really now there's a protocol that Google's been pushing forward called QUIC, which may challenge TCP/IP, and that's 50 years, right? So it's a ridiculous amount of time in a space that we see as sort of fast moving. And this is kind of part of the problem, right? Is that unless you can get a new technology with a lot of committees and agreements of the industry to move things forwards, things stagnate, and what then happens is people kind of work around the technologies. I would argue a sort of a bit like the sort of internet revolution is what I would call the sort of API revolution, which is off the back of these web technologies that really simplified how people can share information and access each other's computers. A bunch of web technology, same web technologies were then trying to be used by other businesses and to communicate with each other. So the idea is that because they had standardized on TCP and they standardized on client-server communication, and even things like HTML, it meant that not only humans could communicate with servers, but servers can start to communicate with servers, and that opened up a whole sort of new set of opportunities. And that businesses no longer needed to operate in isolation. They could rely on, if I think of something like buying something from Amazon, you probably find that off the back of that, that single transaction, there'll be hundreds of API requests. And that's basically just allowing, obviously, that's an interface that allows computers to communicate with each other. But that's allowed someone like an Amazon to say, fine, I use this company for logistics, I use this company for my fraud detection, I use this company for payment, and all of that kind of happens seamlessly to us. But it's really opened up huge opportunities for businesses to kind of leverage off other businesses and no longer have to kind of build everything themselves. But just kind of a little bit of the history of the API economy is that the web technologies themselves weren't actually ready to kind of solve that problem. There were still a few other problems. The first thing was that when people first started trying to use web technologies as APIs, there wasn't consistency in data formats. So I think I mentioned earlier, HTML was a markup format for the web. But in the same way that if I wanted to share some pricing information with someone or stock information, what happened was a whole bunch of organizations, committees again, got together and said, right, what we need to do is come up with formats for prices, for geographic locations, for all these things. And so every different type of data you wanted to interact with, you went and had a standard that you went to and kind of had to look at. And that really just stifled things because it was complex. I mean, that you couldn't just go and just do a request to something and get some information. You'd have to understand the formats, and you'd have to have a big spec that's probably 100 pages long and try and understand that. So the first advance in that was XML, which is extensible markup language, which is kind of a bit like HTML, but that really changed things in that businesses no longer needed to agree on how you structure your data. All you cared about was the semantic meaning of the data. So, and the XML itself would describe the data. So if it was if we go back to locations, it would in the XML describe it as latitude as one field and longitude as another field, and you could read it as a human being and understand what that meant, and you don't need a spec document to understand that. So that changed things dramatically. But then there was a kind of another problem, which is that there was also no standard about how servers communicate with other servers. There was HTTP as a sort of layer which allowed communication, but if you think of something like, again, lat and long, if I wanted to ask the location of something, which should be a pretty trivial request from one server to another, there was no standardization around how you would do that. Like I would, and so everyone would have to come together again and say, okay, well, you're exposing an API, I'm consuming an API, how are we going to agree to do this? And every time you would have to solve this problem over and over again. And again, that stifled the API economy, and that kind of what stopped them happening. So a bunch of pretty horrible, nasty technologies came along. One was called WSDL, and the other one was SOAP, which is still being used, I believe. And they did kind of solve that problem. They provided a sort of standard way of doing things, but it was overly complex. And like what we've learned generally with most of these technologies, as soon as they're complicated, it creates friction and people don't adopt them. So REST came along, which is representational state transfer, and it just simplified the language and the sort of the way in which servers would communicate. And it was off the back of that the first APIs emerged, and that was Salesforce and eBay were really the pioneers of that back in 2000. And Salesforce, I believe, it was really more of a private set of APIs they provided that later became public APIs, whereas eBay recognized pretty early on that they could build a business of the fact that other people would interact with them. So you could be a reseller or a buyer, and you would automate that through and do it programmatically through eBay. And that was really the sort of, you could argue, the success of eBay. How it got so prolific at the time was because all these different companies were selling and consuming data from them. So that's kind of the history of the API economy. I mean, just to sort of give you some sense, there's a directory called Programmable Web, and they list all the public APIs. So there's a lot more APIs than public ones, but there's, I think, over 10,000 public APIs listed there now that are active, which probably, I mean, no one really knows, but that probably means you're in the hundreds of millions of API integrations between vendors. So it's a sort of hidden web of sort of connections between various businesses, but a very important one. I think then sort of really the next thing is, so all of this stuff really is still to do with data at rest, right? It's still static data. You're still sending a request and you're saying, give me a response. So whether that's, as a browser or as a server, people were still, this whole, the technology I've been talking about were really designed for that request response type mechanism. But consumers so what then happened is people like Google came along and realized that they had an advertising business. They wanted people to use the web more and more. That was their business. They didn't want people to use apps. They didn't want people to use native, and they're still trying to do this. They've got their own Chrome OS and all sorts of things. And their incentive is to get people to use web applications, because then they can sell advertising. I mean, ultimately they'll claim otherwise, but that's the reality. So off the back of that, they sort of built things like Gmail, Google Maps, and these things required more interactivity. Specifically Gmail, because Gmail was, you're trying to replace people's desktop email applications, and yet your desktop email application would show in real time as emails came in. And now, prior to Gmail, I think it was probably Hotmail was probably the most popular email client at the time, and you would just have to refresh your browser each time to kind of get that. So the guys at Google did something quite clever. They took this sort of standard, this HTTP protocol, which was designed for, I send a request and I get a response, because there were no real-time protocols that they could use, and they sort of hacked the protocol. And so what they realized was that nowhere in the specification had anyone said when you send a request that you have to respond immediately, because you couldn't do that, because you don't know how long it's going to take for them to process whatever is on their side, or maybe there's latency, or you're far away, or someone has a very slow connection. So there was never a specification around how long you should take to respond to a request. So what they did is they hacked the protocol in a way that when you're in your Gmail client, you would say, hey, have I got any new email? And instead of responding and saying, no, I haven't got any new email, which is the way that it would have been done before, you would just keep polling. You would just keep hitting the servers and saying, hey, you got the email, hey, you got the email, and just kind of keep doing that. They said, well, actually, no, we can do that far more efficiently. We can just not respond and just wait. And so the client will be waiting, and the server will be waiting, and then as soon as an email comes in, it will respond immediately and say, yes, I do have something for you. And that kind of created the first real-time web. That was the thing that kind of gave that feeling of it was real-time, even though in reality, it wasn't a push mechanism. Like, you weren't pushing data to other devices, but it created that sort of feeling of a push mechanism. And oddly, like that technology that they hacked, and I say hack because it is a hack. It's not what HTTP was designed to do. Is still used widely. I mean, it's still used, and that's fine, except that there's a lot of shortcomings in that approach, which we'll sort of get onto why that's a shortcoming. So we've got the sort of data rest versus data in motion. We've got, I think, hopefully, I know there's been quite a lot here, but a lot of these are some basics of technologies that have got us to this point, and how we've sort of created a real-time web. But the thing that's kind of concerning is that the amount of data that's being produced now is exploding. It's not quite exponential, but it's rapidly growing, and consumers increasingly expect real-time experiences. So it's no longer, so you've got this problem of there's more data to process or consume or do something with, and the old way of sort of asking servers and polling for information is no longer really going to work, because there's so much more data. Consumers kind of want this real-time experience, and to participate in this, if you're a sort of small to medium-sized business, is going to be a problem, because your costs of participating in this sort of data economy are going to continue to increase. So what's actually happening really is that the biggest players in the market are not too worried about this, because they, Google, Microsoft, Amazon, they have the engineering muscle, they have the infrastructure, they have everything they need to participate in this economy, and they can kind of do these integrations and build their own proprietary protocols and solve these problems, these real-time problems, and process a huge amount of data. But smaller businesses aren't really able to do that, and the reason again goes back to the technologies, because if you think of sort of like the API economy now, if I'm a small business and I want to take payments using Stripe, and Stripe's probably the business that kind of proved that having a nice API, so making it easy for developers to use your APIs, you could grow a multi-billion-dollar business off the back of that. So there were millions, I say millions, there were many payment providers that were very successful before Stripe came along. Stripe came along, offered a very simple API, and developers realized, there's less friction in taking payments by using Stripe, and suddenly Stripe sort of overtook everyone else. But what helped that happen is that there was a very easy way for developers and suppliers of APIs to do this. Now, the problem with real-time is that with real-time data is this doesn't exist. There's a lack of standards. So we've got TCP/IP as the networking layer. That's fine. That's suitable for the job. And then you kind of go back to what Tim Berners-Lee did, and he had HTTP, but there isn't an equivalent in real time, right? There's a bunch of other technologies. There's WebSockets, there's XMPP, there's MQTT, which is an Internet of Things protocol. There's some queuing protocols. I mean, there's just so many protocols, and there's no standardization. So that's a problem because unlike the reason why sort of the API economy emerged, because people standardized on one thing, this isn't happening. And the fact that we're here now, and there's exponential growth in data, and yet we still haven't solved that problem, is worrying, because of how long is it going to take for us to get to a standard. And in a similar way to what REST provided, which I was saying, the sort of language that servers can communicate with each other, there's nothing like that in the real-time space. So it just doesn't exist. And there's a whole bunch of theoretical papers on how to do this, but nothing implemented, and no one sort of standardizing on things. And then the other thing, which is fundamentally different and more complicated in real time, is that it kind of goes all the way back to the ice analogy again, in that if you're passing data between parties each time, then the value of that data decreases, because the data, sort of, each time there's more latency introduced. So each person has to process it, receive it, and if you're dealing with things where, let's say it's live pricing information, stock information, or scores at a football match, then getting things delivered with low latency is quite important. So in the real-time space, unlike the sort of static data space, you want the person publishing to be able to publish directly to the end user. You don't want a whole bunch of intermediaries along the way, because that's just going to add latency. But so what that then means is, unlike in the REST world, where you would say, if this company is consuming my data, all I have to do is one piece of work, because I'm just giving them, they send me one request, I'll send it to them. Now it's, I have some pricing information for the Australian Open, and there's 2 million fans who need that information within 100 milliseconds. So now the problem is my problem as a person who's distributing real-time data, to get that to 2 million people, as opposed to just handing it off to someone else. So there's a lot of problems in terms of why it's not, there's no sort of silver bullet solution to this. And I think the thing that worries, I suppose I do think is genuinely a concern, is that this will create polarization, right? It's sort of, the web democratized everything, and then now we're sort of moving back to a position where if you want to participate in the sort of real-time supply chain, or the sort of real-time data world, you can't unless you're one of the big players, or unless that's your business, right? And that's like what you do as a business. And this may not seem like, and not to scaremonger, but it may not seem like a big problem, but if you think of machine learning and AI and sort of all the threats it presents, what makes machine learning powerful is the fact that they have data. Like the threat right now in China is that China, at least from America's perspective, is that China has a lot more data on users and what they're doing, and therefore can train their machine learning and AI models far better than America can do that. And because China sort of doesn't really care about sort of people's rights to their data and things, so that's beneficial for them, because as an economy they can actually go on. And so this kind of creates, again, this more polarization, that in the world of machine learning coming along, that if you're a small to medium business and you can't process data in the same way that the larger companies can, then it'll be a race that you can never sort of win. It'll just kind of keep going in that direction. So obviously it's not all gloom and doom. I think there are solutions. And you'd hope that with enough demand, people will, the industry might just come together and force things through. I mean, Google have done that, like with HTTP2, that had been around forever, and proposals, and then Google said, well, we're not going to wait for you guys, and they just introduced another protocol called Speedy, rolled it out on a whole bunch of browsers, and then forced the hand of the committees to just say, okay, fine, and Speedy is basically HTTP2. So there are ways you can force things through, but I'm just not seeing that right now. But I mean, if it becomes a big enough problem, maybe that'll happen. I think maybe the other solution, which is what we're doing, well, our sort of thinking behind it at Ably, is that, well, don't force people into one choice or another for now. Just provide interoperability. So if if one person's using an Internet of Things protocol because they built a device that, I don't know, checks whether a parking space is available. Let them publish into a platform and then let someone else consume from that by triggering, I don't know, a serverless function in the cloud or displaying on a mobile device and maybe using a completely different protocol. And as soon as you kind of decouple the two and just say, well, don't try and couple the two together, and weirdly, it kind of almost against what the internet's about. We believe you actually do need an intermediary. You need like a central point. And I know, like with all the blockchain stuff and everything, it's all about decentralization. But I do think in this case, the way to solve this problem is through centralization and have this sort of intermediary that means, as a developer, when anyone wants to participate in the economy, you don't have to worry about things like whether you're publishing a message, whether it's going to one person or a million people. You don't have to worry about what protocol the people are using on the other side. You just have to kind of stream your data into one place, and the problem of all those, all the complexity around these things is not your problem anymore. So that's kind of the history and the problem and the real-time space. I thought I'd just sort of finish up with maybe just a few things that may be useful. I'm not quite sure the motivation for each of you coming here. So I think there's two areas of real time that that we see really, and so the most obvious one is really like how as a business you deliver real time experiences. And if you forget about the whole supply chain of like how real time data moves between businesses, because a lot of businesses don't need to care about that. They don't need to participate in that supply chain. Then if that's a problem that you're concerned about, then I do think. And this is not a sales pitch for us at all. It's this is a recommendation for however you approach this. The industry is shifting towards the idea that you don't build everything yourself. So like if you're going to try and deliver real-time experiences, find an open source solution that solves that problem really well, or buy in a platform that solves that problem really well, in the same way that no one builds their own email servers anymore and people don't try and build CDNs. It may seem like a trivial thing to solve until it doesn't become a trivial thing, and then you're going to spend a lot of time re-engineering that stuff. There's kind of a lot of confusion between what is a sort of a real-time data and what is a transport. And what I mean by that is you might have a database which stores customer information, and you may want that to be displayed to someone in real time. There are real-time databases which solve that problem. And that's quite different to what a real-time transport is, which is a more generic mechanism of streaming data. So it's not linked to a specific database. It could be, again, pricing information. That's not in a database. It's just a stream of information. So I think if you are sort of, looking at technologies to do that, just realize those are two quite different things and very different use cases. And then again, sort of often with real-time, a lot of the customers we talk to, they've implemented something because they're a very specific need and haven't kind of thought beyond that. And that's, I suppose, just a generic thing. But, by going with something that's more abstract, yes, it's slightly more work up front, something more generic, but it also means that it's, it's not something you have to replace down the line. Last slide was just, if in terms of the data supply chain bit and the whole problem around how that, how businesses share data, I think generally the recommendation there is don't go for proprietary protocols, right? Even if you're using a proprietary platform and you're using an open protocol, at least you're not locked in that regard. So the theory of switching between platforms makes it a lot easier. And if something else emerges, they would probably support the open standards. So kind of go for open standards rather than proprietary lock-in. Data synchronization is incredibly hard. So trying to kind of do a Google Docs type thing over real-time connections is the kind of thing that PhD people are still trying to resolve, and Google have the muscle to do that sort of stuff. It's incredibly hard. Don't underestimate it. And again, there's no standardization on that. Like Google have really gone down something called operational transform, which the general consensus is way too complicated and no one can understand it. And if it's too complicated for people to understand, then they can't maintain it. So there's other technologies that have sort of emerged that are sort of easier to rationalize, but it's really quite a complicated problem in terms of having this sort of idea that multiple people are modifying the same data at the same time. And the final one is like, don't think about the transports, think about the data. Like what we often see is businesses that are sharing real-time data and they're selling their data, but they're focusing most of their engineering effort on how they're going to distribute the data rather than improving their data, augmenting their data with more information. And if they can kind of defer the problem of, well, you worry about my distribution and I worry about the thing that I actually do, which is sell data, or not necessarily sell data, but distribute data because it's valuable to me. That's obviously the thing to focus on rather than the engineering side of things. And that's it. Great. Thanks.